CBI students, hope that you are currently having success in saving Ben's life on Mars. This talk was really meant for the start of the semester, but I required some time myself to see the picture better. So the question is, what do we take home from CBI? And the answer, hopefully you've seen this, is conservation. First of all, conserving our atmosphere. This, of course, is a global challenge, but more importantly, it is about conserving and protecting the soil and water. Hopefully you understand that the latter, soil and water, is a local challenge and that you have developed some tools to understand this better and hopefully later address this issue. So life is all about chemistry. It's really just a dance of atoms forming and breaking bonds. We need the sun as our source of energy. And also, as for the rest, it's all about carbon, hydrogen, oxygen, nitrogen, phosphorus, and the few other minerals that sustain life. Amazing to think that you take CO2 from the air, water from the air, oxygen and nitrogen from the air, and you combine it with some minerals from the soil, and you end up with a complex carbon-based molecule that is really the basis for all life forms. We are really a mere product of sunshine, air, and soil. The sun gives us the energy between the bonds, and from here, all life derives. You might think of the bird as a product of the sun and the air, but without the soil, the bird would not exist. Neither would the CBI class. You have seen through this course, through calculation, that humans are mere vessels for the flow of elements. I have included the sun element in the human body just to indicate the high energy bonds between the elements. So we have a constant flow of elements through the human vessel, and that implies that none of these elements will stay in the vessel forever. Each of them has an associated residence time. It's amazing to think that I can't claim a carbon in my body as a William carbon or a William phosphate. They are merely temporary visitors. While we're talking about vessels and atom flow, we can just as well have a look at a digester, whether it's aerobic or anaerobic. And we can see that it is in a sense very similar to the human vessel. We still have just the inflow of the elements and then various streams containing the outflow of the chemicals. We've performed all the mass balances over them. So even though the products might be slightly different, humans don't make a lot of methane, there is similarity. Just think of urine and liquid digestate. They are in a sense very similar. It's all about harvesting the energy within the vessel and then excreting the elements that you've used to harvest the energy. You also have to spend a few seconds on what water is. Now, water, as you might have noticed, is really the carrier of life. Water itself can carry all the minerals, and it can also carry the complex carbon-based molecules that forms the basis of all life. But more than this, water is also contained within the carbon-based molecules that makes up life. So really, water is the juice that makes it all possible. So before man arrived on this planet, there was only natural ecosystems. And if we have a look at natural ecosystems, it is absolutely amazing to see how these ecosystems has the ability to retain and protect its soil minerals. So there's a constant recycle going on within the soil elements. And even though some of these elements might end up in the water, they tend to be removed, and the water that exits the ecosystem tend to be very clean. Of course, the gas elements will interface with the atmosphere, where we have a globally mixed atmosphere. More importantly is to save the soil, or to retain the soil elements within the soil and within the biosphere itself, so that life can go on. Of course, if you lose phosphorus, if you lose some of these essential minerals, the amount of life in this ecosystem will be less. So nature is the true artist in terms of recycling and retainment. If we have a look at a few ecosystems combined together, you see that I've drawn these red lines. These represent the ecosystem boundaries. Now it's interesting to note that whatever exchange of gas there is with the atmosphere, it is global. There is no boundary in the air. But when it comes to ecosystem, there's always natural boundaries for the soil and the water. And in that regard, the recycle that we've just spoke about of the soil elements remains within the ecosystem. There is no mixing between the minerals from one ecosystem with another ecosystem. And that's the way nature works. When we have a look at man's influence on specifically the soil nutrients, we see a complete different picture to the one we've just seen. So when it comes to the atmosphere, we're very familiar with how carbon dioxide is building up in our atmosphere because of industry. So there is a disruption in the atmosphere. But some people would say even more severe is the disruption of the soil and the water. Because what we now do is we mine the minerals and we synthetically produce the nitrogen, and then we have no regard for ecological boundaries, and we just distribute the minerals or the nitrogen or the phosphate to wherever we want to grow agricultural crops. Now this is truly detrimental for Earth's health. We've spoken a lot about it, but it's really about disturbing nature in its fine-tuned and finely balanced systems. We are polluting the water with minerals and nitrogen, and this causes really major disruption in aquatic ecosystems. Simultaneously, we are killing our soil by applying too much synthetic fertilizer. So we've just spoken about the billion-year-old recipe of nature, of keeping the soil minerals in a tight recycle. And we can see, if we have a look at man and its influence on the elemental fluxes on Earth, we are definitely not obeying the recipe. We are completely ignoring it, and we are accordingly completely disrupting the fine balances that nature works with. Okay, so I've made you aware of some of the issues of human influence on Earth, but let's have a look at our own problem in our own course. By the way, this is Ben. First picture you see of Ben. Ben 10 is not 10 anymore, he's now a man. Okay, now if we have a look at Ben on Mars, that's what you're working currently on, and this is your little flow scheme down here. You hopefully got to the recycle part, and you would have noticed that the recycle of, specifically in our case, it was nitrogen, phosphorus, and sodium, that this recycle is really a major part of our design, because our elements, or our fertilizer, our soil elements, are so expensive to export to Mars. So you might not have noticed, but we had to copy this principle of soil elemental recycle in our application on Mars. So effectively, we were copying what nature has already perfected. Of course, we use some nice microbes from Earth, which makes it easier, but it's important to understand that you are, at this stage in your design, copying a principle, that billion-year-old recipe from nature. And really, if it comes to my own view on sustainability, nature is the true teacher, and learning and copying from nature is the way to go. Okay, so if a third-year student can design a nature-inspired recycle system for a single human being living on Mars, maybe we can just take these principles and just extend it and build it further. They say there's going to be about 10 billion people on Earth in 2050. And I'm saying, well, if we can do it for Ben on Mars, that's one guy, maybe we should aim at doing it for 10 billion people. And I guess that's where you guys in your professions will come in. So guys, just to conclude, we are made of the heavens, the air, and the soil. And accordingly, we have to respect nature's way of recycling and retaining the elements in order to conserve harmony on this beautiful planet. Thanks.